Okay, so we're looking at this triangle here. It is a right triangle, and I know that from this notation. Really important here that we recognize this notation here, this little box in the corner, as a right angle. So that means it is worth 90 degrees. And a right triangle has some fun names that we get to use. We're going to use legs and hypotenuse for the sides of the triangle. So we're going to do legs. There's going to be two of those, and then we have hypotenuse. Hypotenuse. I'm pretty sure I'm spelling that correctly. So the legs are the two sides that form the right angle. So my legs here, I'll try to kind of color code them here. The legs are going to be this side right here, BA, and then this side right here, BC. They make the right angle. Now, directly across from the right angle, as we go through the triangle, that's what's going to give us the hypotenuse. The hypotenuse is always the longest side of the triangle. And here with these values labeled 4, 14, and 50, we can see that that is clearly the case. Right? That is definitely the longest side. So this is our longest side. It's our hypotenuse. And it's typically even the letter C. We'll be using the Pythagorean theorem as we move through this chapter, this content, and the side that, or the equation that relates all the side is a squared plus b squared equals c squared. That's the Pythagorean theorem. The legs are going to be the sides A and B. We typically have a shorter leg and a longer leg, so A would likely be 4. Oh, I kind of labeled it weird. I did the long one and called it 4, and the short one called it 14. But that's okay. Books will sometimes do that. They'll deliberately label things not to scale. So my A would be the short value 4. My longer leg, B, would be the 14. But what's really important is that the C value is your hypotenuse. So my C here is going to be 50. My hypotenuse is 50. Now, the other things we talk about in right triangles are kind of relative sides. We call them opposite and adjacent. So we'll have our hypotenuse, we've already talked about, and then we will have an opposite side and an adjacent side. And this is always relative to an angle. So one of the things that you were asked to do in this particular assignment was to identify an angle. In this case, we were asked to identify angle A. So this is angle A here in this diagram. This little space here I'm coloring in green represents angle A. And from angle A, we have the opposite side and the adjacent side. So that matters kind of where we are in the triangle. As we go through the triangle, this would be our opposite side. So BC is the opposite. So from angle A, so if we go with angle A, our opposite is going to be side BC. That is the side opposite the triangle. And it's often sort of just labeled just sort of a OPP, right? Just a little opposite. And then the other leg is going to be the adjacent one. Adjacent is another word for like next to. So it's going to be this side right here. The hypotenuse is always the hypotenuse. We go across the triangle, we get our opposite leg. And then right next to it, we have an adjacent. So I would go ahead and label this guy as just ADJ for adjacent. So from angle A, the adjacent side, ADJ, would be this side right here, BA. And the reason it matters what angle that we're at is because if I flip the switch and I looked over here at angle C, this isn't opposite anymore. Now, actually, this side over here is my opposite side, and this side is my adjacent. So it's all relative to an angle. So hopefully that clarifies a little bit in a right triangle how you identify your hypotenuse, your legs, and then also once you establish one of the acute angles, in this case A, what's the opposite, what's the adjacent? Message me anytime with questions.